Hello students, welcome to my channel. In today's video, I am going to illustrate the process of integration by parts. So let's see when and how the operation of integration by parts is to be done. Suppose u and v are two functions of x. Right? So we know d dx of uv is equals to u into dv dx plus v into du dx, right? So this means uv is equals to integration u dv dx with respect to x plus integration v du dx with respect to x, right? So now from this we can write integration u dv dx is equals to uv minus integration v du dx with respect to x. Simple operation. So here we get this. Now let us consider dv dx in terms of the other variable. Let dv dx is equals to, suppose I am taking here w. So it means v is equals to integration w dx, right? So here in the place of dv dx we can write w, and in the place of v we can write integration w dx in this relation. So let's do this. Integration u w dx is equals to u integration w dx minus integration, in the place of v we can write integration w dx du dx, and hence this entire function will be integrated with respect to x. So this is the format or rule by which we have to integrate the product of two functions of x or of some other variable by the process of integration by parts. Here we have seen that integration u w dx, where u and w both are the functions of x, is equals to u integration w dx minus integration du dx into integration w dx, and then we have to integrate this entire result with respect to x. So this is the formula, this is the way of integrating the product of two functions of a particular variable, here it is x, by the integration by parts method. Okay. Now here this u means which is kept for differentiation is called the first function. This is called the first function, where this w is called the second function. That means when you will get a sum where you will find that two functions are in the product form and you have to integrate the product of those two functions, then make sure students you have to use the rule of integration by parts, and in that case you have to first choose the first function and then you have to choose the second function, and then you have to use this rule of integration by parts. So we can see that this choice of function, that is first function and second function, is very important for such integration. Now usually we can see the second function is integrated. So obviously the easily integrable function will be taken as the second function. So the other one should be taken as the first function. Now for your convenience, I'll state a list of functions and you have to just follow the order of the functions in that list, because in that list, you will find the function that will come first will be treated as the first function with respect to the function which will come later in that list. So let's see that list of functions. That is, first of all, logarithmic function. That is, this is the first function of the list. Logarithmic function. Secondly, we get inverse trigonometric function. Thirdly, we get algebraic function. In the fourth position, we get trigonometric function. And in the fifth position, we have exponential function. So, as I said, that the function that will come first in this order, in this list, will be treated as the first function, and the function that will come just after it will be treated as the second function. For an example, suppose in any question you are getting logarithmic function and trigonometric function. So in that case, by this rule, logarithmic function will be taken as the first function and the trigonometric function will be taken as the second function. So in many cases, this particular order of function may help you to choose that which one should be taken as the first function and which one should be taken as the second function. Now, to make the concept clear, I have taken an example, a very simple example, and I'll integrate this expression by parts. Okay. So here the problem is integration x into e to the power x dx. We have to evaluate it by this particular method, integration by parts. So let's see how to apply this formula or how to apply this rule. So first of all, look students, here one is algebraic function and the one is exponential function. So just remember the list. There we have found that the algebraic function comes first than the exponential function. So obviously algebraic function will be taken as the first function. So here x integration e to the power x dx minus integration d dx of x, because this first function will now be differentiated, into integration e to the power x dx, and then we have to integrate this entire result with respect to x by the rule. So in the next step, we get x to the power x minus integration. This will give us 1 into integration e to the power x dx means e to the power x. And then this will be again integrated. And hence finally we get x to the power x minus e to the power x plus c. And hence the result is obtained by using the rule of integration by parts. Now let's see another example for making the concept more clear. Here we have to evaluate x sine 2x dx. This is the algebraic function. This is a trigonometric function. Now just remember the list. The algebraic function is coming before the trigonometric function in that list, right? So obviously this algebraic function will be taken as the first function and the sine 2x means trigonometric function will be taken as the second function. So here by the rule of integration by parts we get x integration sine 2x dx minus integration d dx of x integration sine 2x dx, and then this entire thing will be integrated with respect to x. So x integration sine 2x dx will give us minus cos 2x by 2, right? Minus integration d dx of x will give us 1 into integration sine 2x dx will give us minus cos 2x by 2, just as this. Now minus into minus will give us plus here. So we will get cos 2x by 2 dx. Now we have to just integrate this. Now here we get minus x cos 2x by 2 plus half. This half will come outside this integration sign. Cos 2x dx will give us sine 2x by 2, and don't forget to write the constant of integration. So finally we get minus x cos 2x by 2 plus sine 2x by 4 plus constant of integration, and hence the result is found. So today we have got the concept of the integration by parts. In my next video I'll discuss a few more examples of this method. So till then, take care, stay safe. Thank you so much.